Hey everyone, this is Sitar. In today's lecture, we will continue with the chapter Propositional Logic. In last lecture, we studied about what is proposition. Also, we studied about what is an open statement and two types of logical connectives, that is conjunction and disjunction. That means and or. So in this session, we will study some more logical connectives. So let us start. The first one, negation. It is denoted by this tilde sign or this sign. Let P be any statement, then the negation of P is denoted by this symbol or tilde of P, and it is read as not P. If P is true, then not P is false. This is very easy. If something is true, then its negation will be false. In similar manner, if P is false, then not P is true. Now, not P is a unary connective as only one statement is required to form the negation. For example, consider P. Consider the statement P as I like to read. Then, what will be the negation? I don't like to read. Or we can also state like this, it is not the case that I like to read. So, both the cases are same. We can conclude any of them. That means I don't like to read, or it is not the case that I like to read. Now, what will be the truth table? Here, it is as it is a unary connective, we will require only one statement. That means only P. So in truth table, there will be only P and not P. Now here, as it is only one statement, there will be only two possibilities. Either a statement is true or it will be false. So here true and false. So if a statement is true, then its negation will be, we know that it is false. And in similar manner, if it is false, then it is true. That means the negation is true. Now, next connective, conditional connectives or if then. Let here it is not a unary state. Let P and Q be two statements. Then the statement if P then Q. It is the statement if P then Q is denoted by P, this arrow symbol, and it is says like that P implies Q. Again, I am repeating, if P then Q, it is a statement. It is denoted by this P arrow Q, or you can say like this, P implies Q. Now, P is known as, that means the left statement, here we have two statements. The left statement is called a hypothesis and the right one, that means it is the conclusion. That means we are assuming something and Q is some conclusion of that assumption. Remark. Now, P implies Q, that means this P arrow Q, P implies Q, is equivalent to so many terms. So P implies Q is equivalent to P is sufficient for Q, P only if Q, Q if P, Q is necessary for P. So these all are similar terms and we will discuss in examples. P is sufficient for Q, P only if Q, Q if P, and Q is necessary for P. That means all these means that P implies Q. For example, consider a statement P, weather is good, and Q, match will take place. Then what will be P implies Q? P implies Q, that means if something and then another statement. So that means its notation is P implies Q, and the statement will be like this. If weather is good, then match will take place. So it is if then statement. If weather is good, then the match will take place. Note, P implies Q. It is true if both the P and Q are true or both are false. That means if both are true or both are false, then the whole statement P implies Q will be true. Let us consider what will be the truth table. Here, it is not a unary statement, so that means we will require two statements, P, Q, and P implies Q. Now again, we have two statements, so there will be four possibilities like this. Okay, so either both statements will be true, or both will be false. First one is true, second one is false, and first one is false, and second one is true. Now, what will be the P implies Q? We know that here P implies Q is true if both are true or both are false. So here P implies Q, here both are true, so that means P implies Q will be true. The last one, both are false, then P implies Q will be true. Now consider these two statements. Now here it is P and here it is false. So for P implies Q, or to compute P implies Q, just consider here it is P implies Q, that means consider the second, that means the conclusion part. So here the assumption is true and conclusion is false. So the final conclusion will be false. So just we need to consider the second statement. So here it will be false. Again, here it is assumption is false and the conclusion is true. Hence the conclusion will be true. Like this. See, both are true. So here it is true. Both are false. So here it is true. Now here it 2 T and F. So it will be, the conclusion will be F. Again, it is here false, true. Then the conclusion will be true. Yeah, and this one is important. The next logical connective, biconditional, or if and only if, if and only if. Now let P and Q be two propositions or two statements. Then the statement P implies Q and Q implies P, the combined statement P implies Q and Q implies P, is called biconditional or double implication. Now it is written as this symbol P, two arrows, that means double implication, P implies Q, double implies Q, and is known as P if and only if Q, or you can also say like this, P if and only if Q. Now P if and only if Q is equivalent to say P is necessary and sufficient for Q. So these are equivalent. P is necessary and sufficient for Q. That means P if and only if Q. Let us take note. P implies Q is true. Either both P and Q are true or both are false, and false otherwise. Again, P double implies Q is true. Either both are true or both are false, else false. This one is important. Now what will be the truth table? So we will require P, Q, P implies Q. We know that P double implies Q, that means P implies Q and Q implies P. So we will require P implies Q as well as Q implies P and its end. That means P double implies Q and it is same as P implies Q and Q implies P. So this will be the table. So again, we have two statements, so there will be four possibilities. Either both are true, both are false. The first one is true, second one is false, and second one is false, first one is true. Now let us consider this. What will be the P implies Q? Already discussed earlier. Now here both are true, that means it will be true. Again, both are false, so here it will be true. Now for P implies Q, TF. So what is the conclusion part? The conclusion part is false, so P implies Q is false. Now here, what is the conclusion part? It is true, so P implies Q is, here it will be true, just correct it. Now Q implies P. What will be the Q implies P? Both are true, both are false, so here both are true. Now Q implies P. So this conclusion part is T and F, so here it is F. Now we want to find T double implies Q. That means the end in between those two statements. So here, what is end? If both are true, then it is true, otherwise false. So here both are true, so it is true. Here both are true, then it is true. and rest are false. So this will be the truth table. Now, next logical connective, contrapositive implication. The implication not Q implies not P is called the contrapositive of the statement or the implication P implies Q. Okay, so P implies Q's contrapositive is not Q implies not P. Okay, that is implications not Q implies not P and P implies Q. They are contrapositive of each other. For example, if let us consider the statement if in a triangle ABC angle of A is 90 degree, then AB square plus AC square equals to BC square. And the second statement, if in a triangle ABC AB square plus AC square not equals to BC square, then the angle is not 90 degree. These both are same but in a negation form. And these statements are contrapositive of each other. So what will be the truth table? P, Q, P implies Q, not Q, not P, not Q implies not P. So now, again, we have two statements, so there will be four possibilities. Both are true, both are false. First one is true, second one is false, first one is false, and second one is true. Now, what will be the P implies Q? Now you are master in this. So both are true, that means true. Both are false, that means true. Now consider it is P implies Q. So consider this Q column and this the conclusion part is FT. So here it will be FT. Okay. Now not Q. Here TF TF. So here it will be FT FT. Simple. Not P. That means negation of P. TT FF. So that means FF TT. And this implies that means not Q implies not P. So this both are false, that means it will be true. Both are true, that means it would be true. And here what is the conclusion part? FT. So that means here it will be F, here it will be true. Now check these two columns, they both are same as they are contrapositive of each other. Which statements? P implies Q and not Q implies not P. They both are contrapositive of each other, so the truth values will be same. Now, next logical connectives, exclusive disjunction. What is exclusive disjunction? Let P and Q be two propositions or statements, then the exclusive disjunction, or it is also named as exclusive OR, is denoted by P this ring sum. This is called ring sum. P ring sum Q, and the meaning is either P is true or Q is true, but both are not true. Again, it is denoted as this P ring sum Q. Its name is exclusive or exclusive disjunction, and its meaning is either P is true or Q is true, but both cannot be true or both are not true. So let us discuss what will be the truth table. This is not unary, so we will require two statements, P, Q and P ring sum Q. Again, there will be four possibilities. Both are true, both are false. First one is true, second one is false, and second one is true, and first one is false. Now, what is P ring sum Q? That means exclusive or either P is true or Q is true, but both are not true. Here, both are true, so this cannot be true. So what will be P ring sum Q? It will be false. Here, either P is true or Q is true, but both are not true. So here in this, both will be true, and it is false because both are true. So it is false. Here anyone is true, so it is true, and here both are false, so the statement is false. Okay. Now in next lecture, we will study examples based on all the logical connectives. That means disjunction, conjunction, if, then, if and only if, this ring sum, that means exclusive or and or. Now till then, thank you.